One of the primary jobs of any web framework, including Drupal, is to map URLs that someone types into their browser to the code that will create the content for the page. If you want to define new URLs in a module and display custom content on the resulting page, or if you want to understand how Drupal modules like Node or User provide their unique URLs, you'll need to understand how to use routes, controllers, and responses. In this tutorial, I'm going to explain what routes, controllers, and responses are. In order to do so, we'll first take a look at how Drupal responds to an HTTP request and where those components are used. Then, I'm going to provide a more detailed definition of each term to help with understanding what each component is responsible for and how they all fit together. We're not going to look at code yet. That'll be a future tutorial. The goal here is to get a better understanding of how the system works and how module developers can create new URLs. The short definition is that routes are configuration that Drupal uses to map a URL to the controller that contains the code which will generate the response containing the content to display. Before we get into too much depth, I think it'll help to have an overview of how the pieces fit together. Let's walk through the process that Drupal uses to get the content for a page. It starts with the user typing a URL into their browser and hitting enter, directing the browser to request the specified resource. The browser issues an HTTP request, like a GET or a POST, to the URL specified. That request gets sent to the appropriate server. The web server knows how to use Drupal for handling the incoming request and passes control over to Drupal and waits for Drupal to give it back something that it can send back to the browser. Drupal says, "I've got this," and then starts the process of returning the request into a response. First, the HTTP kernel is initialized. Its job is to take the incoming request from the server, which is an HTTP request, and turn that into a PHP request object. Basically, a standardized format for representing the request within Drupal, so that all the other code has a unified way to interact with the request data without having to worry about the nuances of parsing HTTP. And then, the kernel handles coordinating all of the steps that are required to turn that HTTP request into an HTML response. This starts with routing, which is effectively looking at the path portion of the request URL, extracting as much information as possible from the request and making a plan for what to do next. The most important part of this is going to be figuring out what code needs to be executed. Routes map URLs to controllers. Once there's a plan in place, the kernel uses that to execute the appropriate controller and pass the information that it found in the request to the controller so that your custom logic in the controller can make use of it. A controller's job is to use this information from the request to build a response. Things like get info from the database or perform business logic and then create a response to return to the HTTP kernel. A response is the content that the controller wants to display for the user. A response object, like a request object, is a way of representing that information in PHP, which you want the web server to send back to the browser. A response is a PHP object with a common interface. Controllers can return a renderable array or a response object if they need more control over things like HTTP headers or for non-HTML content like a redirect instruction or JSON data. Ultimately, Drupal's going to take the PHP response from the controller and turn that into an HTTP response. Hand that back to the web server, and the web server is going to pass that along to the browser, which can then display the response. And now for a little bit more detail. Routes are defined by modules in a module name.routing.yml file. A module can define any number of routes, each as an entry in the same routing.yml file. Routes also provide Drupal with information about how to parse the URL and extract information from it to pass along to the controller as arguments, and how to do other things like configure access control for the page. Every route consists of a unique identifier, a path that Drupal will use to match against URLs in order to know when to use this route, a controller, which is really the full name of a method on a PHP class that serves as the callback for the route, and additional configuration that provides instructions to Drupal on what it should do when this route is matched. When a request comes in, Drupal gets a list of all the available routes and then tries to find one that matches. This process is called route matching. Basically, figuring out, based on the path option, which route matches most closely to the current URL. The order of operations that Drupal uses for route matching goes like this. First, get a list of all the available routes in the system that might match the current URL. This is kind of like a fuzzy search. This could be it, but I need more information to know for sure. Then, filter that list down using route filters. This will filter out routes applying to other formats like JSON or HTTP methods like POST or PUT that don't match the current request. Next, find the best matching route out of those that are still in the list by applying a regular expression that matches the route's path to the request's URL. After that, the route gets enhanced. This gives other code the opportunity to modify the request before the controller is called. This is most commonly used for doing things like identifying that the integer in the URL is actually the ID of a node, and then loading the corresponding node object so that it can be passed as an argument to the controller, also known as upcasting. After that, access checks are applied. This ensures that the current user has permission to access the route, and finally, you should be left with a single matching route, and the controller defined for that route is executed. A controller is the PHP code that builds the content for a page. In the simplest form, a controller is a PHP class with a public method that returns the content you want to display. The convention is for Drupal modules to put their controllers in the src/controller or src/forms subdirectories. It's not uncommon to see a single controller class with 2 or more callback methods when 2 or more different routes require more or less the same underlying logic. Controllers can access any of Drupal's services via dependency injection, and then use those services to build the content for the page. We recommend keeping your controllers free of complex business logic and instead putting that into a service and then having the controller use the service. This is going to help keep things reusable and easier to test. This is also commonly referred to as thin controllers. Controllers return a response. This might be content to display, but it might also be other HTTP directives like a redirect or stream this file for downloading. A response is defined as an object that is an instance of Symfony's response class or a subclass of it. Response objects encapsulate the content for the page, along with any relevant HTTP headers, into a standard interface that the HTTP kernel will know what to do with. The default behavior for Drupal is for a controller to return a response that contains the data it wants to display. Drupal will then enhance that response by wrapping the content from the controller with the regions and blocks that make up the rest of the complete page, and adding appropriate cache headers and other HTTP directives. A response doesn't have to be HTML though. It could also be an HTTP redirect, a JSON object, a file to download, or any other instructions that can be conveyed via HTTP. Drupal actually contains a handful of useful extensions of the base response class that help deal with adding cacheability metadata to the response or for returning data in other formats like JSON. I think as a rule of thumb, a Drupal controller should use one of the Drupal response subclasses whenever possible. Also, Drupal really likes to deal with content as renderable arrays and not strings of HTML. So if your controller returns a renderable array, Drupal will take care of turning the array into HTML and then creating a response object for you. If you want to return HTML content or forms from your controller, you should do this, return a renderable array, instead of creating the response object yourself. Let Drupal do the heavy lifting. So to wrap it all up, if you want to add a new URL to a Drupal site that displays content or forms based on your custom PHP logic, you'll need to use routes, controllers, and responses to accomplish that. In this tutorial, we learned that routes are configuration that helps Drupal map the URL of an incoming request to the controller that's responsible for generating the page content. That controllers perform custom logic and calculate the content to display and return responses or renderable arrays, and that a response is a PHP object that contains the content or other HTTP instructions to send back to whatever client made the initial request.